Why do some engines last 500,000 miles while others are junk by 120,000? Same planet, same fuel, same traffic. So how is it that a few engines hit 500,000 miles and just keep going, while others are on their second rebuild before they even see 200,000? It is not luck. It is not Japanese magic, and it's definitely not just the brand badge on the hood. There are specific engineering decisions, design philosophies, and real-world habits that quietly decide whether an engine becomes a legend or a horror story. Most people never hear about any of this. They just get told, change your oil and hope for the best. If you're still relying on hope instead of understanding, you're already behind. Subscribe right now, because on this channel, we take engines apart conceptually, explain what's actually happening inside, and show you how to pick and care for the ones that can go the distance. If you skip this stuff, you're gambling thousands of dollars on one of the most expensive machines you'll ever own. Let's decode why some engines can really hit 500,000 miles. At the simplest level, engines are just air pumps, but some are built like bricks. An engine pulls in air and fuel, compresses it, ignites it, and pushes that energy out through pistons, rods, and a crank. Every single one of those steps creates heat, pressure, friction, and vibration. Whether an engine survives hundreds of thousands of miles is all about how much punishment the engineers expected it to take and how much they decided to overbuild it. Legendary long-life engines usually come from a specific mindset. Let's build this to handle far more stress than it will see in normal use. That means thicker engine blocks, stout crankshafts, generous bearing sizes, conservative piston and ring designs, stronger connecting rods, and robust cooling passages and oil flow. Imagine a bridge designed to carry 50 tons, but it only ever sees 20. Now imagine a bridge designed to carry 25 tons that sometimes sees 30 or 35. Which one do you trust in a storm? 500,000-mile engines are that first bridge. Under the hood, they're structurally capable of way more than the car will ever ask from them. This brings us to a secret tuning philosophy, being understressed, not overstressed. Here's a crazy but true fact. Many of the engines that last the longest could have made more power, but the engineers chose not to. This shows up in a few ways: large displacement with modest horsepower, low to moderate compression ratios, gentle red lines, soft, flat torque curves instead of violent spikes, and little or no forced induction, like turbos or superchargers, in many of the longest-lasting examples. From a marketing standpoint, that looks boring. From a durability standpoint, it's genius. Every time you chase high power out of a small engine, you crank up cylinder pressure, temperature, mechanical loading on pistons, rods, bearings, and the crank, plus stress on head gaskets and the valve train. Can high-output engines last? Absolutely, with the right design and perfect maintenance, but the margin for error shrinks. The 500,000-mile legends usually hang out in a safer zone. They're tuned so that peak pressures are reasonable. They don't live near redline. They don't constantly ping on the edge of detonation, and they don't need the absolute best fuel at all times just to survive. They're the marathon runners at 70% effort, not sprinters at 99% every lap. Beyond the tuning, there's a deeper level that almost nobody outside of engineering talks about: materials and machining. These are the tiny details that create a huge lifespan. People love to talk about cast iron versus aluminum, or forged versus cast, and those things matter, but clearances and consistency matter just as much. For an engine to live an absurdly long time, thousands of parts have to fit together within tight tolerances. They have to expand and contract predictably with heat, maintain oil film between surfaces under load, and avoid hot spots that cause detonation or pre-ignition. That means cylinder walls with good surface finish, piston rings that seat properly and seal well, bearings that have the right oil clearance, not too tight and not too loose, and valve guides and seats that wear evenly. Engines that do 400,000, 500,000, even 1 million miles, yes, there are documented examples, especially in fleet use, are almost always products of excellent manufacturing discipline. That means consistent machining, tight quality control, suppliers forced to meet strict material specs, and designs that were refined over years rather than rushed out once. This is why some simple engines from certain brands last forever and others with similar layouts don't. It's not just the blueprint, it's how precisely and consistently that blueprint is turned into metal over and over again. Of course, we can't talk about lifespan without talking about the real lifeline of any engine, cooling and lubrication. Most people think engines die of old age. From an engineering perspective, a lot of them die of heat, oil starvation, or contamination. Long-life engines almost always have very good coolant flow design to prevent hot spots around cylinders and valves. They have excellent oil galleries to get oil quickly to critical bearings and cam surfaces. They have enough oil capacity and volume to absorb heat and contaminants, and they use oil pumps and pickup designs that avoid starvation in real-world driving. Here's a wild but true observation. A lot of engines that theoretically should go 500,000 miles never do because of marginal cooling or lube systems combined with abuse. The ones that actually get there in taxis, trucks, and hardcore daily use often have big radiators, thoughtful coolant routing, strong oil pumps, decent-sized sumps, and sometimes even oil coolers in heavy-duty applications. They're built with the idea that they'll be pulling loads up mountains in summer heat, not just idling in a lab. Another pattern you'll find in half-million-mile engines is simple valve trains with fewer failure points. They avoid unnecessary complexity in the stuff that moves really fast and really often. Valve trains on bulletproof engines tend to be well-proven overhead cam or overhead valve designs. They use conservative lift and duration, reasonable spring pressures, and robust timing chains or, in older engines, belts designed to be changed on time. They're not usually packed with variable compression trickery, ultra-aggressive high RPM cam profiles, or exotic multi-stage systems that add more to go wrong. Even when they do have variable valve timing, and many modern engines do, the systems are usually proven over years, run on clean oil, and designed to fail safe, not grenade the engine. It's not that complex valve trains can't last, but if you're looking for the engines that laugh at 300,000 miles and shrug at 500,000, you'll see a lot of simple, overbuilt hardware upstairs. But even the best design needs clean combustion, and that means fighting a war on contaminants. One of the sneakiest killers of engines is dirty oil. Not just "I didn't change it," but microscopic metal, soot, fuel, and coolant sneaking into the oil system and grinding away over years. Engines that last absurdly long usually burn clean, thanks to good combustion chamber design and fuel control. They seal well with strong rings to keep blow-by down. They manage PCV, or positive crankcase ventilation, properly so the crankcase doesn't fill with acid-forming vapors, and they avoid chronic fuel dilution, where unburnt gasoline washes into the oil.
Fun fact, some older diesel engines in trucks and heavy equipment are designed to run for tens of thousands of hours. They often have huge oil capacities and serious filtration systems, sometimes even bypass filters that constantly scrub the oil. The same principles scale down to passenger cars. Keep the oil clean and uncontaminated, and the engine internals wear slower. That's a huge part of why some engines just keep ticking. Here's a trick manufacturers use that most buyers never notice, involving detuning and commercial versions. They'll take essentially the same base engine and sell it in different power levels. You'll see a high-output version in performance or luxury models, a mid-range tune in regular passenger cars, and a low-output, ultra-reliable tune in commercial trucks, vans, or industrial equipment. Guess which ones end up with the odometer photos that go viral? Usually the commercial or detuned versions. Same block, same architecture, but lower boost or no turbo at all, lower redline, more conservative timing, and sometimes even purposely limited torque. From an engineering standpoint, this is like giving the same athlete 3 different training programs: sprinting, middle distance, and ultra marathon. The body is capable of all 3, but the training you choose massively affects how long they last. Now let's look at usage patterns, like comparing the million-kilometer taxi to the weekend toy. Here's a mind bender.
The engines most likely to hit 500,000 miles are often not babied. They are not driven slowly, and they are not treated like collectibles. They're used every day, hard. Taxi fleets in big cities, delivery trucks, rural pickups, work vans. Why? Because they spend most of their life in the best possible operating window. Warm oil, stable temperatures, continuous running, few cold starts, and few short trips. The worst use for engine longevity is to start, move a kilometer, shut off, and repeat. That cycle loads the engine with condensation and fuel dilution and never gives it a chance to properly warm up and purge. So the engines that last forever typically have two things: a fundamentally strong design and usage that matches what the engineers expected, or better. But usage is only half the battle. The other half is maintenance, those boring habits that produce insane results. There is no 500,000-mile engine in the world that got there on factory design alone. Every single one had help from regular oil changes with correct spec oil, proper warm-up before hard driving, cooling system maintenance like fresh coolant, working fans, and clean radiators, air and fuel filters changed on schedule, and minor leaks and issues fixed before they became major. Mad fact, there are fleet operators who treat oil analysis like blood work. They send oil samples to labs, watch metal content and contamination levels, and adjust service intervals scientifically. Those are the people who take an engine everyone else kills at 200,000 miles and push it past 500,000. You don't have to go that far, but if you change your oil on time, or a bit early if you abuse it, use quality filters, keep the cooling system healthy, and don't ignore weird noises or overheating, you're already doing what 500,000-mile owners do, whether they know the engineering behind it or not. Now, we have to acknowledge the sad reality. There are plenty of engines that could go 500,000 miles, but don't. There are plenty of engines capable of going to 500,000 or more that never make it because the car rusts away first. The owner trashes the transmission and gives up on the vehicle. Crash damage totals the car, or people get bored and sell it long before it ages. In other words, engine design is only one part of the story. The rest is environment, like road salt, bad fuel, and extreme climates. Driver behavior, like constant redline launches and chronic neglect, and economics, because sometimes it's not worth fixing the rest of the car even if the engine is strong. So when you hear that engine can go to 500,000 miles, understand something. It means, under the right conditions with proper care, this design has proven it can go crazy distances. It does not mean every single one will magically do it. So how do you choose an engine with 500,000-mile potential? If you want to own something that could realistically go 300,000, 400,000, or 500,000 miles, what should you look for? Here's the pattern. Look for simple, naturally aspirated engines with a good reputation, conservative power for their size, well-established designs, not the brand-new, untested generation, strong cooling and lubrication designs, a good track record in fleets, taxis, or commercial use, and a manufacturer known for tight quality control. Look around the world. Hilux and Land Cruiser diesels doing brutal work for decades. Old Mercedes diesel taxis in Europe and Africa with odometers on their second trip around the clock. Toyota and Honda four-cylinders in North America regularly cracking over 300,000 miles. Big, under-stressed gasoline V8s in trucks in the US living insane high-mileage lives. Different continents, different fuels, same core lessons. If you want your engine to be one of those stories, here's the fun part. You don't need a brand new car or a fancy badge to own a forever engine. You need the right engine design in a car that isn't rotting away, proof it's been cared for so far, and the mindset to keep doing the basics consistently. You're not just buying what the car is now, you're buying what it can become if you treat it right. If stuff like this blows your mind a little bit, that there's real engineering behind the engines that never die and that you can actually learn to spot them, then you're exactly who this channel is for. Most people will keep saying engines are all the same now and trust whatever marketing tells them. You don't have to. If you're not subscribed, you are absolutely missing out. Every week you skip is another week you don't know which engines to chase, which ones to avoid, and how to keep the one you own alive as long as possible. Subscribe now before the next time you even think about buying, selling, or fixing a car. Think of it like changing your oil. Doing it early saves you from expensive problems later. I'm GearHead. Every engine has a story, and together we're going to decode the ones that actually deserve to hit 500,000 miles.